Hello everyone, Ashley here, and excuse me. I've decided to do this online lecture because we are lagging behind by 1 week, and I don't want to really slow down the pace of this lecture. And also, we don't know what might happen in the near future with the weather and with the coronavirus. So I thought we might as well do something like this, and hopefully it will help you. Now, the chapter today is correlation and simple regression, and I will split this into two parts. So you will have a part one and a part two. So this one is sorry, right. Sorry. So I was saying that we don't know what might happen, and that's the reason we want to do at least prepare ourselves with this lecture. And I was saying that we will split this into two parts. The first part will be theory, and the second part will be some guide on how to use SPSS to tackle this chapter. And the chapter itself is in two parts. So what you can see in front of you is what we were supposed to do as on Friday, and I will do it in two different clips of video tutorials. And uh, yeah, so this is the chapter here. I will explain the meaning of correlation and then simple regression, and discuss a few theories with you, and then see how it goes. If you have any questions, you can email me, and I will collate all the questions and then probably do something similar to answer all the questions. And but what I would like to request is that you listen to this tutorial before we meet next time, which is going to be something similar, but instead of simple regression, the next chapter will be multiple regression. So I do want this to be ready by the time we meet for a lecture in the future. So I will explain the meaning of correlation first and regression. Usually for undergraduate program, they are split into 2 weeks. The first week is focused on correlation, and the second week is then on regression. But we have only one session to cover both. And like I've said, this first part will be on theory, and the second part will be on how to deal with SPSS to do some graphs and some outputs that we have to interpret. Excuse me. Now, the whole chapter is based on having two variables, and if we have variables, for a start, we can consider the variables as x and y. They don't necessarily need to be labeled as x and y. We can change the terms and the names and the labeling, but we want to do the long-term research or analysis would be to do forecast. So for example, one variable could be the days, day 1, day 2, day 3, day 4, and so on, and the other variable could be share price of a bank, let's say some bank. I don't want to mention names here. So this would be an example of correlation where I need to find the relationship. So another word for correlation is relationship, but that's an English term, and I don't want to keep saying the word relationship because the proper technical term is correlation. But in your mind, keep the word relationship so that it makes it easy for you to understand. So correlation would be the relationship between two variables. In my example, I want to find the relationship between days and share price. And the reason I want to do this is because I want to do some forecasting, and that's the whole point. If you've been buying some shares, or if you intend to buy shares, then you might want to look into historical data and how the shares been moving around, and then find a relationship between the days and the share price. And if you see that there is some strongish correlation, then it might be worthwhile then to do forecasts. If the relationship is poor, then forecast would be the least of your worries then. So that's the whole point of correlation, the correlation between two variables. Right now is two variables. The next session, the next lecture will be about we will have multivariables. I will discuss the term regression later. I think it's a little bit too early right now, So let's focus on the regression term. Now, the one example that we have here would be one variable would be years of experience. Let's say I'm a salesman or I'm the manager of a supermarket, and people work at the supermarket and they have accumulated years of experience and they will be making sales. So the point is, my question is, do you believe that the more experience a salesperson has, do you think that that would influence the amount of annual sale the salesman would make? And my answer, if I have to just answer it quickly, I reckon that the answer is yes. I think that the more experience a salesperson has, the most annual sale the person is going to make. So that's another example of finding the relationship, finding the correlation between two variables. And excuse me. Now, if we have two variables, things are easy because they're going to get on the two uh, axis that you are familiar with, which is the x-axis and the y-axis. And the question there would be which one goes on the x and which one goes on the y. And it's quite important uh, to know where they go, right? So I have two variables. So the variables being let me just type it here. So the variables being years of experience, and the next variable being annual sale. Yeah. I don't know how many ends we have, right? So it's two ends. Annual sales would be the next one, two variables. So clearly one will go on the x-axis, one will go on the y-axis. Now, let me just put a label here. I'm trying to put x and y because you are familiar with x and y. That's the only reason, no other reason. But after a while, I'll have to stop using x and y because we have clearly two variables which are perfectly known and labeled properly. Now the question is which one goes on the x, which one goes on the y. So before I give you the answer, I'll give you a hint. Another word for x-axis would be the independent variable. Another word would be the explanatory variable. So you know it as x, you know it as x-axis. From now on, remember, it could be also known as the independent axis and the explanatory axis. Similarly for y, another word, it might be tough for me to type, but I'll try to just type it here. So another word for y-axis would be the dependent axis, variable, and the response variable. Right. So these are terms that I would like you to remember instead of you using x and y all the time. Maybe it's time now to get the proper term that we can use. So think about it yourself and tell me which one do you think out of these two is the independent and which one is the dependent one. So which one depends on the other one? So you can pause the clip here and then think about it. So the answer is easy. All you have to ask yourself is, would annual sale depend on years of experience, or would years of experience depend on annual sale? Right. So clearly, annual sale will depend on years of experience. Right. So annual sale would be the dependent variable, and here the independent would be years of experience. Right, so that's one way to know which one goes on the X and on the Y. I'm going to delete this, right? So it is important to some extent. You need to get this right, but I can give you another clue. Whenever you have one of the two variables being time, space, then it always goes on the x-axis or the horizontal axis. So time is always the independent variable. The problem here is if you have two examples with time, and I think we do have one of them in the PDF file. So if one of them is time, don't worry too much. Ask yourself the question if that suits you, but otherwise you can just write the time variable on the horizontal axis. I do want to stop using x and y right now. I will be mentioning the terms dependent, independent, response, explanatory, vertical, horizontal, and so on. Annual sales and experience, you need to remember where they go. So that would be here, right? So clearly, this is what I think. The more experience someone has, the more sale we expect from that person. And these are the details of what we've just been explaining, right? So let's look at this example with, again, experience and annual sale. And here you go. So experience, years of experience is the horizontal axis, which you know as x-axis. Right now, remember, is the independent axis, is the explanatory axis. The annual sale is the dependent axis, is the response axis, is the vertical axis. Now, I know you have to do this in SPSS, which can be my second part of this lecture. But if I have to quickly sketch it, by all means, try this in SPSS, and you should. But since I don't have any coursework and don't have any assignment and no pressure on me, I'll just try in Excel. So let me start again. So I highlight uh, the whole set of values, click on insert, scatter, charts, and you can get it here, scatter. If you want to put the lines, it's not important right now. So you can just get the scatter point. I personally do not like the grid here, so I can get the scatter point. So this is how the values here are scattered on the on the 1 minute. Sorry about this. So this is how the values are scattered on the graph. Excel can do lots of stuff, so can SPSS. So if I want to put a straight line across this, that's what regression would do, right? So this is what we call regression. Now, it's a little bit too early to explain regression, so right now let's focus on the scatter. This is SPSS output, this is Excel output. They are exactly the same. And let's move on. So the question is how strong the relationship is. Again, I'm speaking English here because I've used the word relationship. How strong the relationship is between the explanatory variable and the response variable. And we want to find this relationship. If I were to use the proper terms, I want to find the coefficient of correlation. This is how it's called. It's here, correlation coefficient, and the notation here is R, and this is what we want to find, and it will just give me an indication of how strong the relationship is between the two variables. Now, briefly, I'm just thinking if we have some graphs here which I can use to explain, right? So yeah, there you go. We do have some graph which I can use. I'm not saying we have to use it, but I can use. Now, briefly, if that's a number line and 0 is in the middle, then my value of R, my coefficient of correlation, will vary between -1. I don't know if my right is the same as your right, I don't know, but okay. My number line will vary between -1. Sorry, did I say my number line? My value of R, my coefficient of correlation, will vary between -1 and 1. So whatever you do, um, whether you use SPSS, whether you use Excel, and we also have formulae, which is known as the Pearson moment for correlation. Whatever you use, your value of y will always lie, your value of r, the coefficient correlation, will always lie between -1 and 1, and clearly 0 is exactly in the middle. So if that's your number line, I'm just trying to put my finger in the at the midpoint, and -1 to 1, and what it means here is when you do the calculation, you can get anything between this given range of -1 and 1. What it means here is that if it's +1 or -1, it means there is a perfect correlation. It means that all the dots lie perfectly on the straight line. I will explain the meaning of plus and minus right now, in a few minutes, but I will repeat before that. I will repeat what I just said. If we have the dots which lie between -1, which lie, if we have the dots and the dots lie exactly on the straight line, or the line lies exactly on the dots rather, it means that the correlation is perfect. We have the perfect relationship between two variables. I can show that to you with an example quickly, and excuse me. So I can find some values of x, some values of y, and let's quickly take some values. Some y values as well. There you go. Let's say I have this pair of variables x and y, and values of x and value of y. If I decide to do the scatter plot, this is what I'm going to get. And if I do decide to put a straight line, don't worry too much what I'm doing right now to get the straight line. I will explain this later. This is one straight line which fits all the dots, exactly on all the dots. So here my correlation is 1, +1. I can do something similar here. Right, so don't worry too much how I'm getting these values. It's not really important. What did I do? +5. Oh, my mistake. Green and negative. Sorry. Let me just think of something else. +50. There you go. Right, so I can have this set of x and y's, and I can decide to do a scatter point. Right, there you go. And trust me, if I decide to put a straight line across this, the straight line will fit exactly all the dots here, and this coefficient of correlation here will be -1. Here the value of r, the strength of the relationship, is +1. Here is -1. So what do you think happened? Why is 1 plus and 1 minus? Both mean perfect. Remember, both are perfect. These are the perfect answers I can get. Plus 1, I don't know, plus 1 and minus 1 means perfect. But what's the difference between the plus and minus? Can you think about it? So you can pause the video here and think about why is this one plus 1 and why is this one minus 1. Right, the answer is easy. The plus and minus doesn't mean good and bad here. The plus means that the line is going upward, that's plus, and when the line goes downward, that's minus. So plus and minus is just an indication of the gradient, of the slope. For those who are not familiar with these terms, don't worry. All you have to think about is upward and downward. So here my value of r will be plus 1 only because it's going upward. So only because it's going upward, that's why it's plus. And you know why it's 1, because the line is exactly lying across all the dots here. If I have to put my r, it will be minus 1 only because 1 means perfect, all the dots, the line, all the dots align with the line, and the minus only means that it's going downward. I repeat, plus and minus doesn't mean good or bad or good relationship, poor relationship. No. 1 means perfect, plus means going upward, minus means going downward. That's what it means. Now, this is just to show you the perfectness, 2 examples to show you the perfect relationship. So when the dots are on the line, when all the dots are on the line, we have a perfect relationship. When the dots are very close to the line, which is probably this case, if I try to plot a line across this, then there you go. So the dots are not all the dots are on the line, but the dots are very close to the line. So clearly it's not going to be 1. The line is going upward, so I expect my value of r to be plus, positive, and I do expect my value of r to be very close to 1, but not 1 for obvious reasons. So my answer should be something positive, right? So what we've, just to summarize quickly, what we've discussed is only the strength of the relationship, known as the coefficient of correlation. We have looked at 2 examples where it's perfect, which means all the dots will lie on the line, hence a perfect relationship. Here it's plus 1, the plus means going upward. Here it's minus 1, it means minus means going downward. Your value of r will always move or fluctuate between minus 1 and 1. And then this example where it should not be 1, clearly because the dots are very close to the line but not exactly on the line. But I hope you understand that whatever the correlation coefficient is, when we're going to calculate it, we have to get a positive answer. I hope you understand that, because the line is going upward, right? So this is what we have here. It's always going to be plus 1 and minus 1, we discuss. If it's very close to 1, it means that there's a strong, because it's very close to 1. 1 is perfect, so very close to 1 means strong. Positive means the slope is positive, the gradient is positive, the line is going upward. That's what positive means. Correlations mean relationship. When it's close to minus 1, it means, remember, minus 1 is perfect, but the line is going downward. So close to minus 1 means it's strong. Minus means negative, which means it's going downward. Correlation means relationship. So that's all right now. So for example, this one, if I were to look at this one quickly, it would be, sorry, we don't have coordinates here, so I don't want to waste time on this one. So that's the first one, is finding r. And like I've said, we also have a formula which we can use, but you don't need to, because SPSS will give you the answer of r. That's the good news. You don't need to fiddle with any mathematical formula to find r. If you use Excel or SPSS, remember your homework will be to try the SPSS as well after I upload the second part. So if you don't need the formula. SPSS or Excel will give you the value of R. Right. Now let's talk about regression, which means how to fit the line. And you've seen the line, but I don't think you followed how to fit it. If you've seen it, fine. If you know it, fine. But the whole point of regression is how do we fit a line, and also how to find the equation of that line. Guys, I think I should stop here because I don't want this file to be too bulky. So instead of 2 parts, I might do more than 2 parts. So this is part 1, where I've stopped at coefficient of correlation. I hope you understood. If you have any questions, please email me and email me your questions, and I will try to collate all the questions and answer them. And that's it. So my next part will be about regression, and we'll see how many parts. It's not really that important. It will take us, we'll do it. It will take all our time to do this. So this is only one lecture, but this is the end of part 1 of that lecture. Thank you very much.